This is 2017, the coordinate geometry question of the higher level junior cert paper. So what we're given here is our lines, and we have to match up which one is which. They tell us here that Q is parallel to S, Q and S, and OR is parallel to T. So what we'll do first is we'll just look down the way here. So remember that these are all in the form y equals mx plus c, where m is the slope of the line. Alright, so the slope of this line is 1, 1, and 2. And c is the y-intercept, so where it crosses the y-axis. So we can see that this line crosses at 3, minus 3, 3, and we don't know. Looking at our graph, okay, we can see that two lines are crossing at the same point here and here. So if I was to just write it in, this is obviously 3, because they're only crossing at 3 or minus 3. So I can write them in. Now let's have a look at the first one. Y equals x plus 3. So that's either Q or OR. So I've got to determine which one's which. So if I look down the way, this one also crosses at 3. So how would I determine which one is Q or OR? Well, this slope is 2, so this one is steeper. So looking at Q or OR, which one is steeper? Q. If I was walking from left to right, walking up a hill, Q would be harder. So this is Q, which means this one is OR. Which means then that I can fill in T. So now I have to work out the equation of the line S. So S is crossing at -3. So I will have y equals, I definitely have minus 3 there. Now the slope of the slope of S. Well, what do we know? We know that S is parallel to Q. If two lines are parallel, their slopes have to be the same. So if it's parallel to Q and that slope is 2, this would be 2x. And that's that one. Alright, working our way down to part B. So use algebra to find the point of intersection of the lines. So there's two ways to do this. Because we know y equals this and y equals this, you could set them both equal. X minus 3 equals 2x plus 3 and solve for x. Or you can do simultaneous equations. I'm going to use the elimination method. I'm just going to stick with what we usually do. So we have y equals x minus 3 and we have y equals 2x plus 3. What I'm going to do is I'm going to choose to get rid of the x's. So I need to make them the same number but different signs. So I'm going to multiply by minus 2 here. That would give me minus 2x, and that's positive 2x. And I'm just going to multiply by 1. Keep that one the same. So let's multiply the top line. Y by minus 2, minus 2y, minus 2x plus 6. And this one will stay the same. And I'm going to add the two lines together now. Minus 2y plus y is minus y. They cancel, which was the plan. And this gives me 9. So positive y then would equal negative 9. And then I have to sub back into an original one. Let's just take the first one. Y equals x minus 3. And I have that y is minus 9. So what's x? We're going to add 3 to both sides. So we get minus 6 is equal to x. So my point of intersection is minus 6 minus 9. And that's that one. For part C, we have the line L is a vertical line. Let's just zoom out a tiny bit here. So we have that, where did I fit all of this in? L is a vertical line, and it's cutting x minus 3 and x plus 3. X minus 3 and x plus 3, so or and t. It's coming down this way, and it's cutting the line somewhere at a point A and B. And they want to know the distance from A to B. So we have no idea where that line is coming down. But what we do know is that or and t, where it's cutting, are parallel. So no matter where that vertical line cuts, the distance between the points will always be the same. So let's just pretend that it was this line here, the y-axis. We have the points 3 and minus 3. So the distance between these 2 points would be the same between, for example, these 2 points. So all we have to do is find the distance between them. Now, one, you could use your distance formula. Alright, you could do that using the point 0, 3 and 0 minus 3, sub it in. Or you might just realize that you can figure out the distance because that's just a straight line. So between 3 and minus 3, the distance would just be 6. And that's that.